So okay,
I'm here to receive more answers from you. If you think math is difficult, give me a yes. If it's not difficult, give me a no. Okay, that's nice. So I can see most of you know how to use the chat room. Okay, so if you have any question, you can type in the chat room. I will see the question and I'll answer you from there. Or you can unmute yourself. If you don't have any background noise, then I'll unmute you, or you unmute yourself, then you ask the question. Okay. Okay, thank you very much. Okay, so probability is all about the study of events. Okay. At this time, can you please all mute your videos so that you can you unmute your videos?
why do I find it difficult?
Okay, so in our daily lives, we make use of probability every day. Every day since we have been in JHS, primary JHS, we have been using probability. Okay, you have maybe used the word maybe, likely, possibly, and other words which denote that what you are talking about, you are not sure whether it can happen or it cannot happen. Okay, so that's probability for you. You were you were doing probability, but you didn't know that was probability, but that was actually probability. Okay. Okay. Now, probability is the study of events which may or may not occur. So, for example, we are in COVID-19. What is the probability that we will be going to school next month? What is the probability that the president will say all schools are open, kids can go to school, safety measures will be put in place? Now, you can assign a numerical value to such an event, that maybe the probability of the president saying that we will be going to school is 0. It is 0 because you think that COVID-19, the cases are rising, and that the president will not allow us to go to school. Is that okay? I hope that's okay. So that's probability for you, assigning a numerical value to a likelihood of an event. If you just say that the president will announce, there is nothing like a numerical value assigned to that. But if you say, oh, the probability of you going to school is 1/5, that's a numerical value and it has been assigned to that event. So that's probability. Now, to know of probability, you have to know of your total sample points, and you have to know about your number of sample points that you are talking about there. So we'll get to this sample point formula there, or the probability formula there. So let's just move off from the probability formula and we'll come back to that one later. Okay. Okay. So if E is an event, let's take that E is an event of COVID-19 happening in Ghana, then the probability of E occurring is noted by P into bracket E, as it has been written there, P into bracket E. So this is what we use to notate that E, which is an event, has the probability of occurring. Now, E bar is not just E again, but what? E bar. Okay, Mike and Yaku, you said you don't understand. We just started, so you understand, okay? Just give it some time. We just started. Okay, so as I said, if E is an event, then the probability of that event occurring is notated by what? P into bracket E. That's the notation. That's why we have the formula P into bracket E equal to the number of sample points over the total sample points. Then P bar is the opposite of the event occurring. So if the event will occur, it is P into bracket E. But if the event will not occur, we notate that one by what? E bar. So E bar is the event that E will not occur. Therefore, the probability of E not occurring is also notated by what? P into bracket E bar. So let's take an example. For the probability that your network will be off during this period of me teaching is E. Is that okay? So the probability that your network will be off during this period of me teaching is E. Now, the probability that your network will not be off and that you stay through the teaching to the end is E bar. Therefore, the probability that your network will go off is P into bracket E. And the probability that your network will not go off is P into bracket E bar. As I explain further on, you will be able to understand more and more. Okay, let's continue. Now we have to know some terms that we use when we are solving a probability question or when dealing with probability. So we are going to define some terms. We have the first term to be what? An experiment. An experiment is any operation whose outcome cannot be predicted with certainty. So if you have any activity, maybe you are writing an exam and you don't know what you are even writing, then it means that you could see that you are failing. That one, the outcome is what? You can predict the outcome. But if you are writing an exam and you have written some, you have not written some, and you are deciding whether you'll be getting that 50% score mark to help you with your class score, or you'll not be getting that 50% score mark, that is an experiment we are talking about here. So with that activity, the outcome cannot be predicted with certainty. Whether you'll be failing or you'll not be failing, that outcome cannot be predicted. So that's what we call an experiment. So for example, let's use the regular probability example. Tossing of a coin. A coin has two sides. That's the head and the tail. Now, when you toss that coin, the probability that you'll be getting a head cannot be predicted with certainty. Or the probability that you get only a tail cannot be predicted with certainty. But you know that when you do that experiment, you'll be doing what? You'll be getting either a head or a tail. So you don't know with certainty what you'll be getting. I hope you get it. Now that's what an experiment is. Now a trial is a subset of an experiment. A trial is a subset of an experiment in that when you have the experiment, that's tossing of a coin. A trial is when you toss that coin. So you have the experiment, you are saying, oh, I'm going to experiment tossing a coin to see whether I'll get a head or a tail. But you haven't even tossed the coin yet. You have not tried it. So that's why we call it what? A trial. So a trial of an experiment is when a single performance of that experiment is executed. So when you execute a performance of that experiment, you do what? You have tried it. Okay, so for example, tossing of a coin, as I'm saying, when you toss that coin, you have tried it. So that's what we call what? A trial. Now the outcome is a result of that experiment. So if you have an experiment tossing a coin, you try it. That's you toss the coin. And when the coin drops, the head shows. That is the outcome of that experiment. You are seeing the head. So you have now the head have shown, and it is with certainty that the head is showing. So that is what the outcome. That is the outcome. So we have the experiment, which is tossing of a coin. That's an example. We have tossing of a die, rolling of a die, and the rest. But the most common example is what? Tossing a coin. When you toss a coin, that is, you are trying an experiment. Now, the answer that will come, or the result that will come, is the outcome of that experiment that you were doing. Now, we have the equally likely outcome. Now, these are outcomes that have equal chances of occurring. They have equal chances of occurring. So if you have a coin and you toss that coin can either produce you a head or a tail. A head or a tail. So the chance of a head appearing is equal to the chance of a tail appearing. I'm not restricting it to only a two-side coin, but we can take a die. Playing Ludo, when you roll that die, now the chance of 1, the chance of 2, the chance of 3, the chance of 4, the chance of 5, and the chance of 6 appearing when that die stops rolling are equal. So when you roll it, it's either you get a 1, you get a 2, you get a 3, you get a 4, you get a 5. And as we most likely, we all like the 6 one. 6 me Ludo, then you'll be shouting. Aha. So that's the chances. So you are trying your chance, you are trying your luck to see if you get the 6. Sometimes you'll be yearning for a 1 and you'll be playing 6. I hope you get it. So that's the equal chances. So instead of getting a 1, you are getting a 6. 6 and 1 have equal chances of appearing. That is what we call what? Equally likely outcome. Now, if you have any question, you can drop it in the chat box. I will look at it for you, okay? We have the sample space. The sample space. Now, the sample space is a set of possible outcomes of a trial. So, for example, if I'm tossing a coin, the sample space is the set of the possible outcomes that can come out of tossing the coin. That's the head and the tail. That's the head and the tail. So if I try tossing the coin, I'll be expecting either a head or a tail. So that's the sample space. So the sample space, let me share this one. Okay. I hope you can all see the blue. Okay, so the sample space of tossing a coin. That is, you have either a head or a tail. Is that okay? You either get a head or a tail. So the sample space is denoted by the letter S. So when I ask you, what is the sample space of tossing a coin? You know that you'll be getting either a head or a tail. Therefore, you denote it by S into brackets, head or what? Tail. Or head, S is equal to what? Head or tail. That's what you mean by sample space. Now, you know that trial is when you try it only once, but you can have multiple trials. That is when you don't try it only once, but you try it maybe 2 or 3 times. So let's take it that you are trying it for 2 times. If you are trying it for 2 times, then the sample space will not just be only a head or a tail. Because for the first time, you'll be expecting what? A head and tail. And for the second time, you'll be expecting what? A head and another tail. I hope you get it. So you'll be expecting either a head or tail for the first one, or you'll be expecting a head and another tail for the second one. So you'll be expecting either, for the first trial, you'll be getting either 2 head. That's when you toss it once. Maybe you get 2 head. Then you toss it again. When you toss it again, you'll be expecting to either get a head or a tail. You toss it again, you'll be expecting to get a tail or a head. When you toss it again, you'll be expecting to get what? A tail or a tail. So that's what you thought. Well, that's what you mean when we talk about the sample space. The possible outcomes that you are expecting to get out of what? That experiment that you are doing. So that's sample space. Any question, you can drop it in the comment section. Okay. Now we have what we call an event. An event is a collection of sample points with a common property. An event is a collection of sample points with common property. So an event is the subset of what? A sample space. So let's say that you have the sample space of, let's say you have the sample space of throwing a die. Is that okay? You have the sample space of throwing a die. Now, an event can be, when you throw the die, what is the probability that you'll be getting an even number? Now, as you can see, getting an even number, it's within the sample space of throwing a die, because the sample space of throwing a die is 1, 2, 3, 4, 5, and 6. That's the sample space of throwing a die. Now, the probability or the event of getting an even number will be what? 2, 4, and 6. That is an event. That's why I said an event is a subset of the sample space of throwing a die. I hope you get it. I hope you get it. Give me a yes if you are following. Give me a yes if you are following.
Yes.
Thank you. Thank you. Thank you. Thank you. Thank you. Beautiful, 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 beautiful. We are on course. Okay, so that's the event. And there are 6 types of events at your level to understand. When you try doing maths in the tertiary level, you get to know more. Is that okay? Thank you, Samuel. So let's talk about the types of events. Let's talk about the types of events. Okay, so the types of events, we have certain events. Certain events. When we say someone is certain about something, you are sure of it. You are sure of it. So when the event that you are looking out for contains all the sample space, that is a certain event. So you have example, tossing a coin. Then the sample space is head or tail. That's the sample space for tossing a coin. Now, you are certain that you either be getting a head or a tail. So the certain event is when you have with absolute certainty that you'll be getting either a head or a tail. That's a certain event. Now, an impossible event is an event that does not contain any sample space points. So you are given the sample space of head and tail for tossing a coin. Then you are asked to find the event of getting 6. Getting 6 or getting an even number out of tossing a coin. How can you get an even number out of tossing a head or a tail? You can't get it. It is impossible. Therefore, impossible event does not contain any sample space points. Now we have what you call the complement of an event. Now, as I explained when I was trying to explain the probability, that's the definition of probability, you could see that there was one which was E and one which was E naught. So we had P into brackets E, which is what? The probability of an event occurring. That okay. Then P into brackets E naught, I'll represent it with a small e since I don't have that symbol here. Is the probability of an event not occurring. Is that okay? So we are using this same logic here for the complement of an event. Now, the complement of an event, let's take it that you have S. You have S to be the sample space of maybe head or tail. Rolling a die and tossing a coin. So let's take it that we are rolling a die and tossing a coin at the same time. So that's the what? That's the sample space. Then you are asked to find the event of having a head. If you are asked to find the event of having a head, you will only be looking for that event in when you are tossing a die. No, when you are tossing a coin, and not when you are rolling a die. Therefore, the complement of that event of getting or having a head is the event that will not happen of when you toss the coin, you will not be getting 1 to 6. So you'll be having a head or a tail when you toss the coin. And you'll be getting 1, 2, 3, 4, 5, and 6 when you roll the die. But you are asked to find the event of having a head. So the complement of the event of having a head is the event of not having 1 to 6. That's the complement. Therefore, it's like in a Venn diagram. Is that okay? In a Venn diagram, you have your union, that's the rectangle. Then you have your circle, one circle inside. That's what we call the event. So that's the circle in there. Now, the event of getting that any other figure inside that circle, the complement of that event is the what is it called? The A bar. I hope you remember that example of Venn diagram. Let me see if you remember. Give me a yes if you remember. Hello? Are you following? If you don't remember, give me a no. Okay, Michael, legend in Boatin, you remember. Nice. Any other person? Okay, Sandra does not remember. Any other? Okay, let me try and see if I can draw it for you. Okay, so this is your Venn diagram. This is your Venn diagram, okay? Sorry. This is our Venn diagram. And we have this circle in it. Is that okay? So the probability of getting an event inside A. Is that okay? This is what we talk about when we are tossing the coin. So you have the sample space all inside here in the U. That's the rectangle. Let me see if I can do something. Okay, so all this place, all this side is what? Our sample space. So we have what? Tossing a coin and rolling a die in this sample space. Now the probability of getting what is inside this circle, that's tossing a coin. Is that okay? It's inside the circle. Now the complement of that event, you see that if you are tossing the coin, then everything will be inside the circle. Then the rest, which is rolling a die from 1 to 6, will be outside the circle. So whatever is outside the circle is the complement of the event inside the circle. That is what I was talking about. So you have something like the A naught like this. Then you have your A. That's what I was talking about. That's the Venn diagram example I was giving. Is that okay? Is that okay? Do you understand now? Hello?
No.
You can unmute yourself and say it if you understand. Good. We are good to go. We are good to go. My guys are good. My guys are good. I like that. Okay, so that's the complement of an event. Okay, that's right. Let's move on. Now we have what we call compound events. Compound events are events that can be combined. So that's compound event. So you have two events, you combine them, it's a compound event. Is that okay? And we have what we call mutually exclusive events. Now you have to remember this one because you'll be seeing it in your questions all the time. Mutually exclusive. The probability of finding a number which is mutually exclusive. I don't know why they love this one, but they like it. Mutually exclusive. I don't know if it's how it sounds, but it's cool. You have to remember it. Okay, I want you to remember this part. Mutually exclusive events. These are events that cannot occur at the same time. Is that okay? They are events that cannot occur at the same time. So you cannot be in school and be at home at the same time. That's a mutually exclusive event. You are not God. You cannot be everywhere at the same time. Is that okay? So you cannot be in school, then you say that I'm home. How can that be possible? That's why when someone sees you in the market, maybe at a party, and calls you, hello, where are you? And you say, oh, I'm in bed. It's not possible. That person knows that you are lying. Okay, you can't be at the party and be in bed at the same time. The next question that will follow will be, hey, so what's that noise that I can hear? Oh, it's from my speakers. But it's not possible. You can't be at the party and in bed at the same time. So that's what you call mutually exclusive events, and you'll be meeting them a lot in probability questions. So if you don't understand, tell me and let me explain it again. Mutually exclusive events are events that cannot occur at the same time. Events that cannot occur at the same time. Okay, since there is no question, I can continue. Now we have independent events. Independent events are events such that one event does not have an effect on the occurrence of another event. One event does not have an effect on the occurrence of another event. So let's say that, let's take an event that will have an effect on the other event. You know that COVID-19 is having an effect on school, right? So they are not independent events, they are dependent events, because COVID-19 is having an effect on you going to school. If there was no COVID-19, Form 3 students would have been writing their exams by now, they would have been finishing by now. And they'll be doing, we thank God, party after party, and the rest. They will be throwing their books around, but now they can't throw it around again since there's COVID-19. So that's an example of a dependent event, that event that affects each other. Is that okay? Now, independent events, let's take for example, let's say an event of you having a laptop during this COVID season. You see that it does not have any occurrence of the COVID-19 affecting you getting a laptop during this season. Because even if you are using a laptop for this online class, it can be for your parents, so it is not yours. Maybe you have been worrying your dad, buy me a laptop, buy me a laptop, buy me a laptop. You are not getting it. Now there's COVID-19 and you think that because of online class, your dad can buy you one so that you use it for it. But out of nowhere, he gives you his and says that use mine. After that, I take it. You still don't have a laptop. So that's an independent event. COVID-19 is not having an effect on you having a laptop. I hope you get it. So that's what we mean by independent event. They don't have effect on the occurrence of another event. Okay. Okay, so before we move to the laws of probability, any question? Before we move to the laws of probability, any question? You can unmute yourself and answer. Okay, so let's continue. So the probability of an event occurring is 1. That's the probability of an event occurring. Oh, I don't like this one. That's the probability of an event occurring. And the probability of an event not occurring is 0. So any other answer that you want in the probability question should fall between 0 and 1. If you get any answer beyond 1, you are wrong. So if you get 1.2, you are wrong. If you get 1.000001, I think that will be termed as 1 because of rounding it. But if you get 1.1, you are wrong. 1.099, you are wrong. So keep it in mind that your probability answer should be between 0 and 1. When you get -1 here, you are wrong because it's above 0 in the negative form. I hope you get it. So whatever answer you get should be between 0 and 1. That's the first law of probability. And it is denoted by the P of E occurring is greater than or equal to 0 and greater than or equal to, it's less than or equal to 1. Is that okay? So it's greater than 0 and it's less than 1. That's it. That's the first law of the probability. Now the second one says that the probability that the sample space will occur is equal to 1. So if we are saying that the sample space will occur, that means that we are going to have an exact sample space. So let's say the sample space is head or tail, and you are asked to find the probability of either a head appearing or a tail appearing. You have been asked to find either one of them. So the sample space is 1. Or the probability of that sample space, that's the whole sample space occurring, is 1. That's for the probability of sample space 2. Now, the probability of an impossible event is 0. The event is impossible. It can't happen in the sample space. Therefore, the probability of an event which is impossible is 0. So if you have been given a sample space of 1 to head or tail, and you are asked to find the probability of getting a 6, you can't get a 6 when you toss a coin. Is that okay? So it is an impossible event, and with that one, the probability is 0, absolute 0. You can't get it. Now, if the probability of an event will occur, the probability of an event will occur, that's P into bracket E. Let's say that it is equal to R. Is that okay? Sorry, 1 second. For that short break, I was talking about the probability of an event occurring. So let's say the probability of an event occurring is equal to R. Is that okay? Then the probability of that event not occurring will be equal to, that's P of E. Let's represent the E with a small one so that we can differentiate it. Will be equal to the 1, because probability is between 1 and 0. So if the probability of the event will occur is R, that's something equal to 1. The probability of that event not occurring will be 1 minus that event not occurring. Is that okay? So probability of the event occurring is R. So the probability of that event not occurring is 1 minus the probability of the event not occurring, and that will be equal to 1 minus R. Is that okay? So let's take an example. Let's take an example. Let's say that if the probability that it will rain, in a day is 1/4. Is that okay? Then what is the probability that it will not rain? What is the probability that it will not rain? Since we know that the probability that it will rain or it will not rain will be exact, that is 1. Then the probability that it will not rain in that day will be 1 minus 1/4. I hope it's clear. Welcome back, Petra. The probability of it raining is 1/4. So what is the probability that it will not rain? Now we know that from our second rule or the second law, that the probability that the sample space will occur is equal to 1. That's this one here. Therefore, the probability that it will not rain will be what? 1 minus 1/4. And that will give us what? 3/4. Okay. That is the probability. Therefore, the probability that it will not rain is equal to what? 3/4. That's what we mean by the event which will not occur is what? 1 minus R, or 1 minus P into bracket E. And it is the same as P into bracket small letter E. Any question? If you don't understand, you can ask your question now. Okay, so if we all understand, let's try solving some examples. Let's try solving some examples under probability. Let's try solving some examples under probability. Okay, let me share the whiteboard. Thank you. Okay, so example 1. So what is the probability of getting a 5 when a die is rolled once. You can write as you follow, okay? Example 1, what is the probability of getting a 5 when a die is rolled once? Is that okay? Now, this will take us back to the probability formula that I showed you before. Is that okay? This will take us back to this formula. And you can write it down. You can write the formula down so that as we solve it, you can use it in solving your answer. There's a probability formula. Okay, so let's answer this question. So it says that what's the probability of getting a 5 when a die is rolled once? So the first thing that you have to do in this question is to find your sample space. And your sample space will be 1, 2, 3, 4, 5, and 6. Because when you roll a die once, these are the possible outcomes you'll be getting. 1, 2, 3, 4, 5, and 6. And we are being asked to find the probability of getting a 5. How many outcomes are in this sample space? As you can see, there are 6 outcomes. So the sample space is equal to what? 6. Since there are 6 outcomes, we have 1, 2, 3, 4, 5, and 6. Oh, okay. So rolling a die, that's when you are playing Ludo. Okay, when you are playing Ludo and you roll a die. When you are playing Ludo and you roll a die, what is the probability of getting a 5 when you roll that die? So when you roll it on that Ludo board, it rolls. What will be the probability of we getting a 5? Okay, So these are the outcomes that you'll be getting. Either you'll be getting a 1, you'll be getting a 2, a 3, a 4, a 5, or a 6. These are the outcomes. So when 1 comes out, we know that we got a 1. When 2 comes out, we know that we get 2. When 3 comes out, we know that we get 3. When 4 comes out, we know that we get 4. And when 5 comes out, we know that we get 5. When 6 also comes out, we know that we get 6. Now, the total number of outcomes in this your sample space is 1, 2, 3, 4, 5, 6, which is 6 number of total outcomes that can come out of this. And now we are looking for the probability of getting a 5. And that 5 is only one outcome. Is that okay? So the sample space is 6 outcomes. And 5, getting a 5 is only one outcome. Therefore, the probability of getting a 5, as you can see, I've removed the E from there and I've represented it with what? 5. E is the event. Event is what? The 5. So what is the probability of getting a 5? 5 becomes the event now. Is that okay? So the probability of getting a 5 is one outcome. That's 1. Out of 6 outcomes. That's 6. Is that okay? You are getting one outcome out of 6 outcomes. Now, this may sound a little bit confusing for some of you because I know we are dealing with numbers. Let's use tossing a die for now and see. Okay, so now example 2. What is the probability of getting a head when you toss a coin once? Okay, that's our second example. What's the probability of getting a head when you toss a coin once? So when you toss a coin once, our sample space will be equal to either we get a head or we get a tail. Is that okay? So that's our sample space. Either we get a head or we get a tail. Therefore, our total number of outcomes in this sample space is head, which is 1, and tail, which is 2. So our total number of outcomes in this sample space is 2. That's why in this first example, our total outcomes is 6. Okay, so the head and the tail of a coin is simply it's normally chosen by the participant. Okay, we don't particularly have one part of the coin which is head and one part which is tail. It is chosen when you are on board. Like for example, when you are going for a football match. Is that okay? And the captains both go and the referee says that choose one. Now, the first one will choose and they'll say, okay, this is the head. Then the second one will choose and say, this is the tail. Now, when you toss that coin, the side that will come, which the first person chose, and they called it a head, is called the head. And the second part that will come, when you call it a tail, it's called the tail. So we don't particularly have one side which is called a head and one side which is called a tail. It's because for a coin in so many different countries, we have different types of inscriptions on the coin. So sometimes in a particular country, we have everything, the currency and the picture and everything on one side, and the same thing at the other end. Yeah. I'm talking about the money coin. The money coin. And it's for all other coins that are in the world, okay? Because we don't have a particular inscription for all coins, then you can say that this is the head. As in a die, when you are playing Ludo, you roll the die, you know that there's 1, there's 2, there's 3, there's 4, there's 5, and there's 6. But for a coin, when you take 1 CD, we have different inscriptions on it. When you take 2 CD, you have different inscriptions. When you take 50 pesos, you have different inscriptions on it. So the participants will choose which side is the head and which side is the tail. That's the coin for you. So the probability, the sample space will be 2, either a head or a tail. So you have either the head or you have the tail. Welcome back, Michael. So we have either the head or we have either the tail. So the probability, the sample space is what? 2. That's why in the die, rolling of a die, our sample space is what? 6 outcomes. So the sample space for this one is 2 outcomes. Now, the question says that what is the probability of getting a head when you toss a coin once? So the probability of getting a head, as you can see, I didn't represent that one with 5. I've represented it with what? H. So the probability of getting a head is equal to, the head is 1 outcome. Out of that 2 outcomes. So the probability of getting a head is 1 outcome out of that 2 outcomes. So probability of getting a head when you toss a coin is 1/2. And the probability of getting a tail when you toss it is also 1/2 because it's the same 1 outcome out of 2 outcomes. Now, let's go back to this die example since you have gotten any question. If you don't understand, give me a yes in the chat box. If you don't understand, give me a yes. Okay, we thank God we are all rolling. We are all rolling. My guys are good and I like it. Okay, so now since we understand the number of outcomes and the outcome number, let's take the first question, which is the sample space of 6 outcomes. Which is the sample space of 6 outcomes. And we only found the probability of getting 1 outcome. Now let's find the probability of getting an even number when you roll the die. I hope you know even numbers. Yeah, as you are thinking, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That's an even number. So what's the probability that when we roll that die on the Ludo board, we are going to get an even number? Is that okay? So we find our sample space, and our sample space is equal to 1, 2, 3, 4, 5, and 6, as we have already established in the first example. That's our sample space, as we have first established in the first example. Now, the probability or the event of getting an even number will be equal to the even numbers in this outcome. So we have how many even numbers there? We have 3 even numbers, which is 2, we have 4, and we have 6. So since this one is equal to what? 6 outcomes. And this one is also equal to 3 outcomes. Since we have 1, which is 2, 2 is representing 1 outcome, 4 is representing the second outcome, and 6 is representing the third outcome. So the probability of getting an even number, or the event of getting an even number out of rolling a die on a board, is 3 outcomes. That's you either get a 2, you either get a 4, or you either get a 6. Therefore, the probability of getting an even number, as you can see, for the first example, I represented it with P into bracket 5. Second example, I represented it with P into bracket H. The third example, I'm representing it with P into bracket even number, which shows that whatever is in that bracket is the event, the outcomes of that event that you'll be getting. Thank you. So the probability of getting an even number will be the 3 outcomes out of the 6 outcomes in total. And that will give us what? 1 out of 2 when you simplify it. Just probability for you, as simple as that. Is that okay? Any question? Any question? Okay. Since there's no question, I will drop. Okay, thank you, Sandra. Thank you, Sandra. Since there's no question, I will drop a question here. I will solve it for the first time. That's I'll be solving for the last time. Then for the next one, when I drop it, you solve it, and I will mute you for you to give me the answer. So do well and participate. Is that okay? Okay. Now in a class of 20 boys and 35 girls, what is the probability that a student selected at random is a boy? Okay, so this is the question. In a class of 20 boys and 35 girls, what is the probability that a student selected at random is a boy? Okay, good. Now, what you need to do is to find your sample space, as I've been doing. So you find your sample space. It's denoted by S. Is that okay? So our sample space will be equal to the total number of students in the class. Since it says that in a class of 20 boys and 35 girls. So the total number of students in this class will be 20 boys. 20 boys plus 35 girls. That is the probability of, that's the sample space that we are working with here. Is that okay? Now the event of picking a boy, will be equal to the number of boys in the class. That is what? 20. So in a class of 20 boys and 35 girls, our sample space is what? 20 plus 35, which is equal to what? 55. So the event of picking a boy is the total number of boys in the class, because if you are picking a boy at random, you can pick any boy out of those 20 boys. That's why the event of picking a boy is the total number of boys in the class. Therefore, the probability of picking a boy will be equal to the event of picking a boy all over the total sample space. I've missed it. So that's equal to the event of picking a boy over the total sample space. And the event of picking a boy is 20. And the total sample space is 55. Therefore, the probability of picking a boy, or the probability of a boy being selected, is 20 over 55. And as you know, we can simplify this to its lowest term, which will be 4 over 11. For essay students, I know you have your calculator on board, so I will not be asking you such questions. Yeah, okay. That will be what? 4 over 11. So as you can see, when you punch this 4 over 11 in your calculator, that's 4 divided by 11, you will be getting 0.363636363636. Is that okay? So as you can see, this answer is between 0 and 1. It is between 0 and 1. Now, the last question I'll ask and solve it myself is, what is the probability of picking a teacher in that class? What is the probability of picking a teacher or selecting a teacher in that class? Anybody with an idea? You can unmute yourself and talk. Hello? What's the probability of selecting a teacher. Yes, Calvin.
Sir, that's 0.
0, that's right. Good one, good one. Beautiful, beautiful. Thank you very much. So the probability. Okay, Sandra also says 0. That's nice. That's nice, Sandra. That's nice, Sandra. The probability of picking a teacher in that class is 0 because you aren't giving a teacher in the class. You are giving 20 boys and 30. God bless. That's nice. 0, 0. That's nice. I like it. I like it. My guys are good. I like guys who are good though. That's nice. So there wasn't any teacher in that class at that moment. So the probability of selecting a teacher in that class is 0. Yeah, okay. Beautiful one there, Florence. Beautiful one there, Florence. Yeah, okay. So now I'll put the question on board. You have about 3 minutes to solve, and I'll be demanding my answer. I'll not be collecting, I'll be demanding it. I like demanding. I don't like collecting. Okay. So this is the question. A number is chosen at random from the set S is equal to 4, 7, 10, 13, 16, and 19. What is the probability that the number is okay? So that's it. You can send me the answer through the chat room. I'll read it for you. Or you can unmute yourself and give me the answer. Please, I would like all of you to participate. I would like all of you to participate. I would like all of you to participate. So you have about 3 minutes. Okay, Teresa.
Say.
Yeah, since you are done, can you give us your answer?
Say even number.
Yeah, even number.
3/6. But if you break it down, you get 1/3, 1/2.
Beautiful, beautiful. Nice work done. Nice work done.
Should I say it first?
Yeah, you can continue.
2 odd numbers. 3/6. But if you break it down, you get 1/2.
Okay, that's nice. That's nice. That's nice.
Between 7 and 16.
Okay.
3/6.
You get
3/6.
okay.
When you break it, you get 1/2.
Okay.
That's 15.
Yeah, and less than 15.
You get 4/6. If you break it down, you get 2/3.
Beautiful, beautiful, beautiful. That's nice. That's nice. Any other? Okay, Sandra, that's nice. That's nice. That's nice. That's nice. Any other? I'm waiting for more answers. I didn't say they are correct. I just said beautiful, beautiful, beautiful. So bring your answers on board. Yes, Samuel.
Sir, A, even number.
Okay.
1/2.
Okay.
Odd number, 1/2.
Okay.
Between 7 and 16, 1/3.
Okay.
Less than 15, 2/3.
Okay. That's nice. That's nice. That's nice. Any other answer? I've had 3 answers out of 15 participants. Not encouraging, please. Oh, let's see, out of 30. Out of 13 participants. Not encouraging. More answers, please. You can send it to me in the chat box, or you can unmute yourself and say it. One minute more. Okay, God bless. God bless. That's nice. That's nice. Michael, that's nice. That's nice. Any more answers? Okay, your time is up. Okay, Kelvin. That's nice, Kelvin. Okay, so let's try solving them and see if we are correct or wrong. As I said earlier, I didn't say anyone is correct or anyone is wrong. I was just saying beautiful and that's nice. Okay. So our sample space will be 1, 2, that's 4 is 1, 7 is 2. So 1, 2, 3, 4, 5, 6. So our sample space will be what? 6. Our sample space will be equal to 6. The event of getting an even number will be equal to, what are the even numbers in here? We have 4, we have 10, we have 16. So the event of getting an even number is 3. Therefore, the probability of getting an even number will be equal to what? 3/6. And that will be equal to 1/2. I hope you are marking yourselves. Okay. Then the next one, the probability or the events of getting an odd number will be equal to 3. Therefore, the probability, which shows that we have 4, we have 13, and we have 19. Therefore, the probability of getting an odd number will be equal to 3/6, which will be equal to 1/2. Now, between 7 and 16, the event of getting a number which is between 7 and 16. I'm using the shortcut because I'm teaching. Please don't be using it, okay? Event between 7 and 16 will be 7 is not past because it is between. So 10 and 13, which will give us what? 2 over what? 6. Is that correct? Is it correct? Any counter answer? Yeah. So I have a supporter, 1 over 3. Yeah, Sandra, thanks you for supporting me. 1 over 3. Yeah, okay. So you get 1 over 3. Then the last one, which is less than the event of getting a number which is less than 15, will be equal to numbers which are less than 15 ranges from between the number 16 and 0 here. So we have 13, we have 10, we have 4, and we have 7. So that will give us 4 events or 4 outcomes out of 6 outcomes. And that will be giving us 2 on 3. Is that okay? So that's the answers. I hope you have marked yourself. Maybe you were wrong somewhere. Maybe you have seen it and you have corrected yourself. Okay. The next question. Hey. Okay, so we have about 3 minutes more. So let's do one more question. A bag contains 100 identical balls. 40 of which are blue and the rest are green. Find the probability of picking at random a red ball from the bag. Okay, so you have about 2 minutes to go. Sorry. B. Find the probability of picking a green ball from the bag. Okay, so let's go. Very good, Daniel. Daniel has given us a first answer. Okay, the second answer also dropped. Okay, Sandra, nice. Michael, beautiful. There are 2 questions, Daniel and Michael. Let me separate them for you to see. You can also unmute yourself. God bless, that's nice. There are some people who are not talking. They are not either chatting or they are not sending messages. K17. Hello, K17. Nice one, Florence. Florence has also dropped. Daniel has dropped the second answer. Nice one. Michael, I'm waiting for your second answer. Teresa, I'm waiting for your answer. Are you around? Wisdom. Okay, Wisdom has spoken. That's nice. Wisdom has spoken. Wonder. Wonder, I've not seen you speaking or writing here. Can you drop your answer? Hello, Wanda. Can you unmute yourself? Okay, Wanda has dropped. Nice. He's following. Okay, that's nice. That's nice. But K17 is not around though. Teresa is in the building. That's nice. I don't think they are coughing. Okay, beautiful. Beautiful answers there. Beautiful answers there. I like it. Okay, there's a hand up. Sandra. Sandra, you can unmute yourself. Yeah. Yeah, K17. K17. Oh, okay. Okay, Sandra, okay. K17, answer Samuel. Nice answer, Samuel. Okay, so let's solve it. It says that a bag contains 100 identical balls. Therefore, our sample space, that's our total number of the sample, will be what? 100. Now, we want a number of what? It says 40 of which are blue. So number of blue balls is equal to 40. And the rest are green. Therefore, number of green balls is equal to what? 100 minus 40. Which will give us what? 60. Nice one, Wanda. Nice one, Wanda. Nice one. So solving for the first one. Find the probability of picking at random a red ball from the bag. So as you can see, in that bag, we only have blue and green balls. So the event of picking a red ball will be equal to 0. And therefore, the probability of picking a red ball will be equal to 0 over the total sample space, which is 100. And that will give us 0. Now the B, it says that we should find the probability of picking a green ball from the bag. So the event of picking a green ball from the bag will be equal to 60. Therefore, the probability of picking a green ball from the bag will be equal to 60 over 100. which will finally be equal to 3/5. Your essay students, I know you have the calculators. You will now be doing the cancellation, okay? Like we'll cancel the zeros behind, and after that, 6/10. What numbers can you use to divide both of them? 2. 2 divide 6 3 times. 2 divide 10 5 times. That will give us 3/5. But since you're essay students, you have your calculators by you. I know by now you have answered it. Okay, so as you can see, a lot of you had it correct. 3/5. Oh, beautiful, beautiful. Oh, a lot of you had it correct. Those who couldn't get it correct, I hope you have found where your mistake is and you have corrected it. Nice, 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 nice. So that's probability for you. We couldn't do the addition. Okay, so we are left with 2 more laws in probability, which is the addition law of probability and the multiplication law of probability. Okay. Please, I hope the time is up or I can continue.